So what I want to do here is show you how to go from the unit circle, where every point on the unit circle, its ordered pair, the coordinates, are cosine x, sine x, where the angle is x. So we're not plotting x on the axes here. We're saying here's an angle, and we imagine what the angle would be, and then we see where the angle intersects with the unit circle, and whatever that point is, the x coordinate is cosine x, and the y coordinate is sine x. Now, what we're going to do is show how to go from the unit circle to just extract the graph for sine x. There's a cat. So what we want to do then is imagine that we're standing right here where the circle intersects with the x-axis. And I put a point there, and since we only really care about sine x, I just marked down what its y-coordinate is. At this point, the y-coordinate is 0. And as we move along, say we're strolling along the circle, then we go through all the angles. This angle is 0 radians, and would go up through pi over 4 radians, and we go up here to pi over 2 radians, and when we get to that, we'll have the y value of 1. And so that's meandering through quadrant 1, and we'll continue to do that through the 4 quadrants. And as we do that, we're going to plot over here the x, meaning the angle that's being formed by wherever we are on the circle, and the sine of x, so that's what's up here, is sine of x, the y coordinate of the point on the circle. And so one thing that I want you to see is that these angles, as we go through the circle, these angles are going to map out here linearly. So we go from 0 to pi over 2. This is quadrant 1. And then we go from quadrant to cover quadrant 2, we go from pi over 2 to pi. And so that's quadrant 2. And then we go from pi to 3 pi over 2. So this is quadrant 3. And then as we go from 3 pi over 2 to 2 pi, to complete the circle, that gets us to 2 pi, and that's quadrant 4. So this is how we're going to go through the angles. As we're swooping around the angles here, we're plotting the angles here. And then as we're swooping around the angles, we're seeing how they intersect with the unit circle, and we're only plotting the y-axis over here. And then, of course, these markers here are pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So I can put those little marks there. And that helps us see what's going on. So when we're here and the angle is 0, our y-coordinate is 0. So we start there. And as we sweep through the angle up to pi over 4, our y-coordinate becomes 1 over the square root of 2. And so 1 over the square root of 2 is approximately 0.7, so we'll mark that once we mark down this maximum value. When we sweep up to pi over 2, we see that this is the top of the circle. This is the largest the y-coordinate will ever be, which means 1. So here's 1. And so that means that here is 0.5, there's about 0.75. So when we sweep from 0 to pi over 4, then our 0.7 is about there. And then we sweep from pi over 4 to pi over 2, we jump right up to 1. And as we're sweeping, the values are moving continuously. So we see that they're doing this. And we see that sine is increasing from 0 to 1 throughout all of quadrant 1. Now that we're done with quadrant 1 and we start sweeping through the angles into quadrant 2, so from pi over 2 to 3 pi over 4 to pi, we see that we've already maxed out at 1. We're coming back down to 0.7, or 1 over the square root of 2. So that's going to be about there. And then as we continue on to pi, the sine values are dropping back down to 0. So we have this. So we see that sine is decreasing as we are going through the second quadrant. And these are smooth curves. This is not a bumpy or pointy thing. So now you can see that this part here maps to this part here. Quadrant 1 increasing to pi over 2, we hit its max at 1, and then we decrease as we go to pi as we travel through quadrant 2. And so as we travel through quadrant 3, we see that our sine values are now negative. All of our y values are negative in quadrant 3. And we're going to go from pi to 5 pi over 4 to 3 pi over 2. And the lowest value, the bottom of the circle, is -1. So if we have about the same distance, then this is -1. And we know we hit that at 3 pi over 2, which I'm going to change that up to here. And so we hit -1 at 3 pi over 2. And so we're sweeping from 0 at pi, and when we hit 5 pi over 4, we're at -1 over the square root of 2, or about -0.7. So that's about here. And so we see as we swap through or swoop through the third quadrant, we get this sort of downward curve. We see that sine is decreasing in the third quadrant, just like it was decreasing in the second quadrant. Well, now we've hit our bottom value, and as we start moving from -1 for the y values and we swoop through the fourth quadrant, we see that the y values, the angles are going from 3 pi over 2 to 2 pi, and the y values are going from -1. It hits the -1 over square root of 2 here at 7 pi over 4, and then it goes back up to 0. So there's our 7 pi over 4. It hits about there, and so we swoop it, and we end up back at 0. So that's one lap around the circle. We see we're from 0 to 1 in the first quadrant. We're going from 1 to 0 in the second quadrant. We go from 0 to -1 in the third quadrant, and then -1 back up to 0 in the fourth quadrant. As we pass through the angles 0 to pi over 2 to pi to 3 pi over 2 to 2 pi. That's just one lap around the circle in the counterclockwise direction. If we wanted to continue this graph, we would just keep going. And so we would do 2 pi plus pi over 2, and that would give us this look, but over here. So it would continue going like that, and as we swoop around the circle, it would just keep going in a wave. And the same thing is if we started here, which is this point here, and we went around clockwise, we would then be getting the negative angles, which is what we would have over here, the negative angles, and as we're going in the negative direction, we immediately are heading down to -1, so we see that the graph would start heading down like this. But the whole graph, one lap around, looks like this, from here to here, one lap around at 2 pi. And so all the others are just more laps around. It's the same shape, but on and on forever and ever in either direction. That's how we go from a circle, a unit circle, where the points are cosine x, sine x for their coordinates, their ordered pairs, to a single graph with just sine on it. Now, I'm going to describe this in the lecture next, but we do the same thing to do for cosine. It's just that when you start here for cosine, the x-coordinate is 1. And so instead of starting here, we would start up here. But then we do the same thing. We go from x equals 1 to x equals 0. So it would just swoop down like that for cosine. So it's the same shape. It's just like the circle's been twisted, and we start here at 1, which is this guy moved over here, and we get the same shape going through.